Hello everyone, and thank you for attending today's webinar, Segment Routing, the Unified Tunnel in the Future Network, sponsored by Huawei. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can submit your question to our speakers via the Q&A box. All questions will be saved, so if we don't get to answer today, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. Finally, an on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to Principal Analyst in Optical Networking and Transport at Heavy Reading, Sterling Perrin. Sterling?
Hi, thanks, Hannah. Thank you, everyone, for joining today. Let's get right into it. So our speakers today, I'll be just doing a very brief introduction on the topic of segment routing, and then hand things over to our primary speaker, Gang Yan, who is a senior architect in the routing domain with Huawei. And we will also, not presenting, but we do have on hand for Q&A portion, Alan Hu, who's a senior director in the fixed network group of Huawei. So those are our presenter and then our Q&A participant. And this is the agenda for the next hour. I'll provide an introduction of segment routing in terms of definition and putting in context of standardization. And then Gang will take us through the rest of those bullets there, looking at networking trends, challenges with traditional IP MPLS networks, a deeper dive into segment routing, and then some views from Huawei's perspective about the evolution of segment routing, and then the Q&A portion at the end. So just in terms of defining segment routing, a couple of terms that are used and can cause some confusion. We're talking today about source routing or segment routing, essentially synonymous terms used to describe the same concept of routing packets through the network. In this source routing approach, we have an ordered list of instructions that's applied to an MPLS or applied to MPLS labels at the source node. So that's the source routing naming of the technique. The label stacks provide all of the instructions that these packets need to get to their end destination. So if you look at the diagram on the right, the source router, the source node R1, has the segment info and the MPLS header. The destination router in this very simple diagram is R6, and all of the instructions needed to get there start from the very first router. In this case, we show just 3 labels. Again, it's a simple diagram, but in reality, we have seen several studies have shown that not all destinations, but most destinations can actually be reached with just 2 or even 1 label being applied. So that's one aspect of the simplicity of this technique and why it's of interest. The other key point is because that information is all encoded in the source node, there is no requirement for the intermediate nodes along the route to maintain a network state. So again, this is a simple diagram with just a couple routers, but you can imagine a national network with many routers through. None of those intermediate routers would need to maintain state. So this is really one of the big reasons why segment routing is a much simpler approach to traditional MPLS traffic engineering approaches, which have always struggled due to the complexity. RSVP-TE would be one of those, and so this is many service providers are viewing segment routing as a more efficient and simpler way to do what RSVP-TE has historically accomplished. Our speaker, as I said, will provide the details on the mechanics and how segment routing works, as well as some of the use cases. But the last point I did want to make before handing things over to our speaker is just a word about Spring, that final bullet point on the slide. SPRING stands for Source Packet Routing and Networks, and it's the IETF standardized form of segment routing that is becoming very important today. And so there's a number of different RFCs addressing SPRING. I've just cited RFC 7855 on the slide, which is a good introduction to the problem statement and the requirements that segment routing's addressing, and you can find a way to different RFCs from there. But it's a very important development in terms of standardization. We think that lack of standardization was one of the biggest barriers to moving forward, and now that we see standards coming to light in the IETF, we are seeing a huge uptick in service provider interest, and I think one of the big reasons why segment routing is such a big discussion topic this year, and again, part of the reason why we have this webinar today. So with that, let me just advance the slide forward here. I'll hand things over to Gang Yan, and he will talk us through the rest of those bullet points I showed in the agenda. So Gang, you can take the presentation from here.
Okay. Hello, everyone. Here is Yan Gang from Huawei, from Huawei development team. Right now, we put more effort to develop segment routing MPLS and SRV6 to try to provide more function to our customers. Okay. So at first, maybe we can review the evolution of network. Actually, from our view, there are three stages. At the beginning, it is the traditional network stage. Even the technology is changed from the native IP to MPLS, but its basic characteristic is similar. Sorry. It is a distributed system, and our device execute the function based on predefined protocol, and depend on the different configuration, different device will be different roles, and all of these devices work together to provide the service to customer. And actually, this network it looks work perfect, but because currently the requirement have some change, so this network also this kind of camera also should be improved, and we know this kind of network is a little difficult to add some new service. When they want to add a new service, they have to upgrade the software, and sometimes the whole network, the resource usage is not optimized. It is a problem. So in order to resolve this kind of issue, the SDN the control plane and the forwarding plane is separated at the beginning design. The controller is deployed, and it will control everything in the network. And the device just receives the forwarding table and from the OpenFlow protocol, and execute the packet forwarding directly. At this time, it looks the new service can be deployed quickly. Just the controller will be affected, but we can say its reliability is not so good, and the convergence of network failure always be completed in the controller. Actually, it's slow. Sometimes it cannot satisfy all requirements. It looks the SDN network is cannot be big. So based on this question, so the network, the controller is keep on evaluated. So the controller is just changed to new style. Some control function is go back to the forwarding device, and the controller is just looks like execute some automation of some like optimization and fault recovery, this kind of function. So at this time, controller IC network is for optimized network is not control whole network. In traditional, the LDP and RSVP is deployed, but at this time, it looks this two kind of protocol is not so good to the network. So okay. It is.
Hey, Gong, before you keep going, are you able to speak either a little louder or closer to the mic? We're getting a comment in that it might not be loud enough.
Okay. I will. How about now?
That's much better.
It's better.
Thanks.
Okay. I will take care of this one. So now we can say the trends of IP protocol evolution. Okay. About automation, I think we know the integration with the NMS or controller. The cost is very big. Many protocols should be integrated. So in order to support the automation, the protocol simplify is very important. Right now, it looks like we have many protocols. Like for service, we have VLL, MPLS, and L23 VPN, many kind of VPN service, and those service is paired by BGP or LDP. Sometimes we can say the tunnel. Okay, we have LDP tunnel, and we have sometimes we can deploy the RSVP tunnel. So we know we have to configure many different protocol, different configuration. Also, we know different vendor. It's command line is different style. So its integration is the cost will be very huge. But in the future, all VPN service will be supported by eVPN protocol, and its configuration will be more like L3 VPN, and the BGP will be only service paired protocol. And at the same time, the LDP and RSVP will replaced by MPLS by segment routing. Right now, it is MPLS segment routing. In the future, I think the SRV6 will be deployed also. Also, for management plan, okay, maybe we have netconf, we have telemetry, but finally, its data model will be YARN model always. It is YARN model driven management. Okay, we come back to have a look what is the gap of the LDP and RSVP. So it's about LDP. It's just driven by IDP routes for the device get IDP routes and distribute the label for all of these routes. So when they select the LDP, we have to face some issue. The first, we have the control plan is more complex. We have to deploy the IDP and the LDP together. Also, due to they have two different protocols, so sometimes when the system have the failure and sometimes the failure recovery, we need to distribute IDP and LDP synchronization, this kind of protocol. It's like this way, when the failure recovery, the IDP will be convergence at first. But at this time, at this link, no LDP label is distributed. So at this time, the IP is okay, but MPLS is not working. We just at this time we just need a synchronization filter to block the IP route switchback, and after the link gets the LDP label, and then based on the IP routing switchback, the LDP also will work fine. So at this time, this process is very, very complex. Also, due to the LDP is just based on the IGP routes, so no traffic engineer function. It is LDP's problem. About RSVP, we know the problem is due to we need a signal to build the tunnel between the source to destination. So there have the scalability issue. When we want to distribute many RSVP tunnels, the signal, the device pressure will be high. Sometimes the device, some key point, it looks like this kind of key point cannot accept so many RSVP tunnels. Also, the RSVP tunnel don't support ECMP. Okay, even we have some protocol to support it, but it is not popular now. Okay, so we can have a look what is the SAM routing. Okay, actually, somebody already introduced that. We just go through it in brief. SAM routing is just don't like LDP and RSVP. They don't need a signal to distribute a label one hop to one hop. They just need the IGP to take this global label flood to full network, and the controller will use this top logic and the global label information to calculate from A to H a label stack. One label is one SID, and it will be identify the whole path. This path can be follow the route, and sometimes can be defined in any way. So about SAM routing, there have some advantage. At least its protocol is simple. No, only have IGP, no LDP, no RSVP. Also, its scalability is very high because no any signal to notify each node to identify the tunnel. Also, due to we can define the forwarding path manually, so its programmability is very, very high. Finally, we know in the SAM routing there have TLRFA and anycast protection, also have the SRTE, FR. So its reliability is also will be better than traditional protection feature. Just like traditional LRFA FR, IGP LRFA FR, it only can protect 75 scenarios, percent scenario, and so it's following future remote LRFA is only just around 90% future protection, but TLRFA is can achieve the 100% protection. So we can say right now the SAM routing, it is MPLS SAM routing. its forwarding plane is MPLS. Right now, at this scenario, no LDP, no RSVP. Before the IP packet, it is a MPLS label stack. One label is it's just to identify the forwarding path. In the future, due to just like IPv6 deployed and 5G or IoT, even or cloud, the MPLS routing will be to the SRV6. Its forwarding plan is changed to IPv6 forwarding, and still no LDP. We can say its packet is different. In the IPv6 packet, a new header, SRH header, is added. There are a set of IPv6 like label. 128 bits is one label. At this time, one label can have more program capability. We can say one label can have two parts. One part to indicate the locator, which device will receive this packet. Another part means in this locator, in this device, which kind of function will be killed. Just like we can support L2 VPN, we can support L3 VPN, and so on. So this kind of evolution is just to help the network to support E2E function. E2E network visibility, visible, and E2E service deployment is because traditional MPLS is just have a self-domain, where its programmability is just from MPLS ingress to egress. But due to SRV6 is IP forwarding, so it is more easy than MPLS to support E2E deployment. Okay, so it is advantage of SRV6. We compare with the traditional technology and SRV6. It is from one DC through the DCI to another DC. Within DC, it is IP and plus VXLAN. So, and the traditional DCI is MPLS, LDP, or TE, or MPLS routing. So it is the gateway. In the gateway device, we have to mapping from VXLAN to MPLS L3 VPN or L2 VPN. At another side, we need to map the L3 VPN or L2 VPN back to VXLAN with I. But in the future, in SRV6 scenario, it provides the chance to support E2E support, E2E service deployment. So it is, we think it is the advantage, the most important advantage of SRV6. So okay, this page is from Huawei view, how in the future the network, how to select the technical direction. Okay, right now most network is IPv4 MPLS. Okay, maybe it is LDP or RSVP. So we think this kind of network can be to the routing IPv4 MPLS routing directly. It is a good selection, but it is here is about IPv6 MPLS. Actually, I think maybe nobody want to improve their network to IPv6 MPLS now, because right now the industry it's pure integrated. in the industry. Also, we can use IPv4 MPLS plus 6PE to support IPv6 functionality. Also, from the IPv4 MPLS segment routing, we think the next hop is SRV6 directly, not IPv6 MPLS segment routing, because in the future the network is data center centric element. I think we need the protocol unified in the data DCN and the DCN network. Also, SRV6 is easy to support cloud network, and it has more programming capability. While the new service, the new APP can be deployed more easily than MPLS segment routing. It is Huawei's view. So also about segment routing, one function is very, very important. How to migration from the traditional MPLS to MPLS segment routing or SRV6. Actually, now Huawei already supports those functions. One scenario is interworking. The left side is from the LDP domain to left side is segment routing, right side is LDP domain. So we just deploy the segment routing matching server to support it, and then the whole network migrate to SR only. Another kind of scenario is we can deploy the LDP and the segment routing together. We can use tunnel policy to select tunnel from the LDP tunnel to segment routing tunnel. Then we remove the LDP deployment. Then to accomplish the segment routing deployment. Also, all of this is segment routing current progress. Actually, for segment routing, they also have new challenge. It's just like for 5G solution. We know the slicing is the most important feature in 5G solution. For different service, maybe different slice will be needed deployed in the physical network. At this time, maybe there have some different selection. One is with traditional TE tunnel. It can perform. The performance can be guaranteed by RSVP-TE resource reservation, but there have some the scalability problem. Another selection is SR-based solution. Actually, right now it looks like SR is widely accepted in the future transport network. The protocol will be simple, and the network and the status maintenance is less, and higher performance in the large network. But right now, segment routing also need some new extension. Just like right now, the segment routing haven't resource reservation and assurance capability. Right now, Huawei is researching in this one. Also, how to the strict isolation. It is also have relation with resource reservation. Finally, is scalability integration between overlay and underlay network resource. All of this have relation with resource. Huawei is trying to do our best to get some solution to support this kind of future. So okay, my presentation is finished. So hello.
Okay.
My presentation.
Thank you.
Yes.
Yep. So let's move into the Q&A. We've got actually quite a few questions have come in. Let's just advance over to the Q&A. So good. And I believe we do have Alan Hu on the line. Alan, are you?
Yes.
Live? Okay,
so I try to respond everything by text, but maybe I can go through the question again.
Let me. I can ask.
More, yeah.
We can ask the
some
questions
questions.
live.
If I don't, I need Yan to support it, and we can try to answer it one by one. Is it okay? Or how to do it?
I can just
open the
go
line
through some
and
questions.
can jump in.
Right. So we like to go through them live, and then if we don't have an answer, that's okay. But let me just see if I can get through a couple of these ones with you. So one of them came in about OAM in segment routing, and so maybe if you could just address that verbally for the other folks on the audience as well. How do you deal with OAM in segment routing?
Yeah, a typical OEM, we still enable core BFT to trigger a lot of stuff in the OEM layers. So BFT still is the main tool to use to address OEM for segment routing.
Okay.
And
we had a couple that reference specific slides. Let me see if I can. Let's see. So there was one came in. If I can get this right, a picture with the data center in segment routing V6. Is that a vision or a commercial product?
Yeah, I just tried to respond by text by answer it. Actually, segment routing. If you check the segment routing called SRV6, we're working on it. It's not purely say it's mature enough. But it is not the visions. We work on it. There are a lot of features we put on the product. And if you check end-to-end side, from data center to another data centers, that's probably not commercial available at this time, but the majority of the features we already supported on the product. I would say it's coming, not the vision, but it's coming maybe next year we can do some lab tests to do work on end-to-end stuff, yeah.
Okay, and then maybe a related question from me on that. So aside from this particular slide on segment routing V6, you went through a number of slides on the webinar about showing in V4 implementations. Could you clarify how much is your production network today within the V4 MPLS segment routing? Is all of that production-ready network, or was some of that future-looking? And just trying to get a sense of how much is deployed today versus how much is more future-looking.
If you check right now the segment routing side, we mostly focus on the service provider network. So we work with a major carrier like SoftBank, and some I know European operators also looking for it. And I would say at this time, majority job focus on the Japan carrier, the SoftBank. We deploy them, and some like the Vodafone they're looking for it. And that's kind of majority focus on service provider network. But if you do like end-to-end from DC side to cross the service provider backbone, so that's some part is probably not ready yet, but that's we work on it. It says for service provider network, we are from product line side, we pretty much can support it on the oldest called NE series routers, from our side, yeah. But we still improve because SR, MPLS, or SRV6, some are not mature enough, some still in the draft stages, but some drafts are already supported, yeah, even in the draft stage.
Right. Okay. Okay, good. And let's see, we actually got quite a few questions in. Yeah, so there was a question, this one. Let me go to the slide. This was from early on in Gang's presentation. Hold on one second. I'm just going to push the slide to the audience. So hopefully that's up. So the question was, how does the third model with the controller at the node improve network reliability? So that's the evolution with an SDN network scenario that hopefully everybody can see. Can you just address that in terms of reliability?
Okay, so actually, before I discuss the gens, and I would say we work on some specific stuff to improve reliability. Originally, we have one dedicated slide to explain how to enhance the reliability. I'll emphasize only, and we can have some scenario, and nodes combined with the controller, we can avoid not just the fast reroll, we can avoid some micro loop scenario. So I would say we can count more scenarios to improve the reliability. So all the fast reroll timing, we can control less than 50 milliseconds. That's pretty much the answer from me. So if you want a more detailed implementation side, probably need R&D support to explain. I would say originally we have one dedicated slide to explain this. So there's a little bit technical to explain a little more. At this time, I would say we do cover more scenario to failure scenario, and we still can guarantee all the fast reroll time less than 50 milliseconds.
So is the reliability part of the segment routing the way it's standardized, or is that the way each vendor implemented in the network?
That's something called TI-FLA. That's a kind of a protocol we're using. It's kind of standardized. Yeah, but we try to enhance more feature on it to improve it. Yeah.
Got it. There was a question. Go ahead.
Yeah.
Yes.
Okay. About this one, maybe I can add some additional information about this reliability issue. Actually, the third picture and the second picture and the third picture, the difference is the forwarding device still have some control, just like the local convergence. When in the failure process, each node still handle it. It can have faster convergence. It can have the deployed calculator, the TLFA, some FR function. Don't like the second picture. All of this kind of calculation will be done in the controller. Okay, sometimes we can say the forwarding device also can support the FR, but all of this calculation have to be done in the controller. Its work will be very, very huge. But the third one is each one still has its self-control. It's so we can deploy more local convergence functionality. Just like TRFA, it's each node based on the whole topologic to calculate how to protect the link failure or node failure. Yeah.
Okay, good. Thanks for that explanation. So let me move back to the Q&A here. Question about quality of service in the slicing. I believe maybe, well, I'm not sure which slide it refers to, but question is, what about quality of service per slice in segment routing? Are you able to address that question at all?
I would say that QoS per slice is kind of not directly related to SR probably. Yeah, just like 5 GB slicing and end-to-end slicing. We do have kind of all you push is called like Ethernet channel stuff. We do have called control try to combine together to network slicing. When you're slicing, you need like a port or physical port to be sliced. All the nodes have to be sliced together. And once you slice it, and each layer, slice layer, you still can enable QoS on it. Yeah. So the slice, the physical layer, you have the slicing, make you isolate the resources, and then on top of that, you still can be QoS still can enable on that slice because that's already separate from others, the physical layers. So I would say not for SR, but for the just generic layers, how to do QoS on slicing. Yeah.
Okay, and it looks like we may have gotten through all of the questions we had in the queue. So why don't we, let me just push out the survey here for the audience. If they can, if you can take a moment to fill out that survey, should be popped up on your screen. And yeah, with that, I think we have run through the questions. So let's close out here. I want to thank Huawei for sponsoring and taking us through the slides and also answering a number of questions. And thanks to the audience for tuning in today. So thank you, everybody, and this will conclude the webinar.